That's right, guys. I'm starting a city gen. I know, no one saw this coming, including me. We're gonna be looking how to set up full-on intersections, T-intersections, dead ends, and make sure that it's all possible to work with perfectly straight roads as well. So whether you're making a curved road or a perfectly straight one, it will work. And so today, we'll be going through all of it. It'll be a slightly longer video, most likely. I guess no better time to start than the present. Let's get into it. Now, we're gonna need two things here. The first one is we need some kind of assets for the road. I'm using good old Kenny. Kenny stuff is free, Creative Commons, and basically I have taken his road set and we'll be using this as our kind of foundation for the roads. This will work with any road system you have, so you don't have to use these meshes specifically, but in my case, I'm using a full-on cross intersection, a T intersection, and a dead end. And all of the stuff you need will be linked down in the description below, of course. So aside from this, I'm also going to need to use PCGEx, and it's still available all for 5.7. You can get it here, 5.6 and 5.7. The only reason you haven't seen it on Fab is because Fab has kind of pooped itself and refused to update it, basically. So Tim, the creator of PCGEx, has had to figure out other ways of publishing it. So right now, on Gumroad, you can get it fully for free for the Windows build. For Mac and Linux, you have to compile it yourself. I can't help you with that one, but if you need help, you can always join his Discord. I'll try to make sure I have it linked all in the description below. But if you're doing just Windows, the instructions are very easy. You download it, and you basically put it into your project's plugins folder, or make a plugins folder if you don't have one, and you just put the PCG Extended Toolkit folder there. And you just need to launch the engine, and it says enable the plugin, but usually when you put it here, it'll automatically get enabled, but good to double check. So we will be using PCGEx, and we're using 5.7, because that has the latest and greatest. And if this series goes long enough to go into 5.8, if there's some cool stuff with that, we'll start progressing into 5.8 and newer stuff and make sure everything is updated. Now, aside from that, we also need to have PCG itself enabled. So under edit plugins, search for PCG and make sure you have the extended toolkit here enabled and the base procedural content generation framework enabled, as well as the geometry script interrupt also enabled. Extended toolkit will enable this by default. It might enable this as well. Just double check that all three of these are on and restart your engine if needed. The only other thing I want to note is under the Kenny assets that I've brought in, if I bring any of them in, they're quite small is the first thing. I mean, that's fine. We could always scale them, and I do in this tutorial, but the normals of them aren't always great. They sometimes have like soft edges where you don't want them to have. To fix that, you can do that just in the modeling toolkit here by going to selection mode, modeling, go to attributes, normals. If you change from use existing topology to per triangle, you'll see right there, this is where it was. And per triangle, you can see that highlight there kind of works a little bit better. It is no longer a soft edge here. It is kind of a hard edge as you would expect. So you set it to be per triangle and just hit accept. And that takes care of the normals. And the only other thing that I've done is on the road straight mesh, I've just gone ahead and added a few more loops here. Although I think this is not displaying correctly because it has nanite on. If I disabled nanite, you can see there's the full loops all the way through. I'll go ahead and renable nanite though, but just know that the loops are going all the way through. It is just a straight line right now. But that's pretty much all the kind of prep and setup that I've done in terms of assets and plugins. So now we can get into it. And by get into it, I mean, I'm going to draw out the actual road system. We're not even going to do the PCG graph yet. We're going to draw the road. Now, I would love to use the PCG mode for this, but unfortunately, draw spline will keep overriding the spline. So instead, what I'm going to do is use the modeling tools. Instead of PCG mode, I'm going to go to modeling. I'm going to go to draw spline. The output mode will be an empty actor. I'm great with this. I just want a simple actor with a spline, and I will have free draw here. I'll set the spacing to be something like 500. And now if I come here and I just click and drag, you'll see I can just draw out a spline. Now 500 might be a little bit too close. Let's make it like 1,000 maybe. I'll hit cancel out of here and go back to a spline and draw a new one at 1,000. And we'll draw something like this. That seems good. Then you hit accept, go back to draw spline. Everything's still the same. Empty actor, free draw, 1,000. We can draw another one that's kind of going through here. Again, hit accept and basically go through and draw a few roads. Now, when I intentionally draw a few T intersections, so maybe something like this. So that way this would become a T intersection. Maybe we'll have a dead end over here. So we'll have another T intersection, cross, a couple of dead ends, a dead end over here, dead end there. That seems good. I also want to go ahead and draw a straight one. So instead of free draw, I will do click auto tangent and I'll just set up kind of a straight section here. So I'll just go maybe from here to here, accept, draw spline, here to here, accept. Basically, so we could test out fully straight lines lines and curved lines. So there we go. Something like this we can start with. This might be too small. This might be too big. We haven't put the roads in, but something like this gets us a good test area. We have straight, we have curved, we have four-way, we have three-way, and multiple types. We have dead ends. Perfect. Now what I'm going to do is just in the outliner, I'm going to select all of these spline actors. Then I'm going to go in the detail panel and search for tag. I'm going to give them all an actor tag. The actor tag will be road. So I know all of these are roads, and I'm going to right click and say move to, create a new folder, road splines, just to keep these organized already. Things are going well so far. Let's go ahead and start with a PCG graph. Let's right click, go to PCG, and grab ourselves a PCG graph. This is going to be an empty graph. This is going to be our PCG underscore city gen. And then I'll go ahead and take it and just drag it out into the world. I'll put it at origin, and I'll just scale it all the way to fit this entire area. I'll make it something 250 by 250 by 100, which is about the size that I made this, which was just 50, 50, and 8. I'll also go ahead and just take these and kind of center them a little more. This area, again, this is just so it'll be easier to work with in case I want to expand a little in any direction. We're good here. Let's go ahead and now open up the PCG graph. And of course here we can get started by getting all those splines we created. Just do get spline data. And in the spline data, we want to get all world actors by tag. This is going to be a road. We want to select multiple, and this will get us all of the splines. And now we just go from here and do a simple spline sampler. We want it to be on the spline, but instead of subdivision, it'll be distance. And the distance will be something like 500 by default. I'm also going to enable fit to curve. Fit to curve basically makes it so if it's just a little bit more, a little bit less to make it perfectly fit, it will adjust that 500 to be a little bit different to make it basically 500 equally. But it's not exactly 500. Since we don't care about it being exact, this just makes it so it fits better inside of the curve we drew. Now this value, this distance increment, I actually just want to expose this. So in the bottom left, I'm going to add a new parameter. On new property, I'll hit F2 to rename, and I'll rename this to road distance increment. I'll set it to be 500 by default, and then I will drag this out, open it, and this will go into the distance increment. This is purely so I can control this later on if I so wish to. Now if I try to debug this and just press D and the bottom left corner, open up the PCG city gen and select the PCG component here, you'll basically not see much of anything because the actual debug is way too small. So I'm just going to do a bounds modifier, and we're going to scale this. X is the forward axis, so I want to just scale it here in the Y and Z. I'll scale it to be something like 200 in Y and Z just to make it visible. And now if I debug the bounds modifier here, you will see that there you go. There's all of our roads. Now, quick note, if you do not see your debug in the world, just press A. If you just go A and A, just turn this on and off, that typically refreshes the display, and then you will actually see your debug in the world. That's just a common bug here in PCG, so that should get you the result, and then you should be able to see your quite large, thick splines here. So this is great, but the main thing we need to do now is actually get the intersections, which is basically anywhere where it intersects here, where it's close enough to intersect. We want to know where all of these positions are because, well, we need to put intersections there. So we can make use of one of the new nodes by right-clicking, searching for spline intersection, and this takes a spline input. So we'll just go ahead and take this tagged road one, plug it in. It does give you a conversion node. I can't explain to you why, because I would think that this is a spline and this is a spline. Visually, it's the same, but if you hover over this, it says subtype polyline, and this is subtype spline. I guess under the hood, they are different, but for our sake, it is spline and spline. The main thing here that we want to do is turn on output spline indices, and instead of outputting the original splines with intersections, we want to get the intersection points only. This will enable both of these. We're going to keep the name by default, and the distance threshold here, I will change to be a little bit bigger, something like 50. You can even make it 100, and then in the detail panel, change it from extents to absolute, something like 5x. You will see there's our points there. Point there, except right here where it's just not close enough. I'll just take this and just move it a little bit closer, and you can see now it is overlapping. And if we take a look, pretty much everywhere where we have an overlapped section, we now have a point. Fantastic. There we go. I've changed the ground here and the lighting, so it should be much easier for you guys to see. You have all these points, but it does not include the dead ends. So we want to include those. Thankfully, that is very simple to do. With a spline sampler, we can just drag out here, filter elements by index. And what we want to do here is not select indices by input. We don't want to do it by input. We want to specify them. We want to specify index 0, which is the first one, and index -1, which is the first one from the back. So while they start at 0 and go forward, 0, 1, 2, 3, 4, if you're looking at the last one, it is -1. So the second to the last one will be -2, then -3. So if you don't know the length of it, this will just take care of that problem. So this will grab the first and the last, and then we can do a merge points here, grab one and the other, and again, debug it in absolute 5. And now we have these points at the end as well. So these are all our intersections or dead ends. Now, if I come and zoom into them like this, you'll see we have highlight 2 points here. It's kind of hard to tell, but you can see there's 2 points right on top of each other there. Here again, we have 2 points right on top of each other. We don't want multiple points on top of each other. Same thing here. We only want the 1 point. To fix that, we'll just use a simple collapse points node, and we can pretty much leave it at default. Again, debug it, absolute point scale 5, and you'll see a lot of them have kind of turned into 1 now, which is great. These are kind of 1, this is 1, and you'll see over here it is still 2. That's because we just moved this a little bit too far forward. If I move it back closer to this intersection, we'll get back to 1. Same thing here, it's a little bit too far. We can adjust this and bring it in closer so we have a 1 point. It is possible to have it be a longer distance by changing the collapse points radius here to be, let's say, 1,000, but then you'll see that the point kind of moves away from the intersection. So personally, I prefer to keep it at a small value, and you just control where you position the road a little more. So awesome, we have our intersection points. So let's name it just that. I'll drag out and search for a named reroute declaration node. I'll press F2 to rename it, and these are our intersection points. So fantastic, we have these. Now we need to remove them from the original. The original ones have the intersection still as part of these, and I want to get rid of those points. So that way each spline here will be its own segment. So for that, we can just drag out and then use a difference node. A difference node needs to be set instead of minimum to binary, and we're removing the intersection points here. If I debug the difference node now and make sure to stop debugging the bounds modifier, you'll see that we now have a little bit of a cutoff at all of these intersections. Now, it doesn't need to be perfectly in the middle. That is fine. That's not a problem. But the main thing is this is now a segment. This is now a segment, right? And it's been split between all of these. So the next thing to do is actually split a spline into multiple segments in terms of its data. So right now, the spline, if you were to use a create spline node, would still create one continuous spline. We want each one of those segments that's had a piece removed to become its own piece. And we can do that by using indexes. When you create a spline originally, you start from the start at index 0, and then maybe you'll have index 1, 2, 3, and 4. But what happens when you remove this index? Well, the index of this is no longer 3. It is now 2. And the index of 4 becomes 3. So it becomes 0, 1, 2, 3, which means the difference between this number and this number is 1. 3 minus 2 gets us 1. 1 minus 1, which is going to be the original, will get us 0. And if we had another one afterwards and removed another number, the next segment would be 2, and then 3, and then 4. So by using the indexes and subtracting from the original values that they had with the new values that they have after cutting out that intersection piece, we know the kind of the segment number of that spline. So we can then take that spline and then separate it and partition it by those segments, resulting in each segment having its own spline. That might have been a little confusing, but don't worry, we're going to set it up and you'll see it in action. The first thing is we need to store the original splines indices. So from this bounds modifier, I'll just drag out and use a copy attributes node. Plug that in right before the differences here, and we'll make the bounds modifier go into the target and the source. And all we're doing is for input source, we're going to hit the plus button and select index. So store the index onto something else. You can't put it back on itself. So I'll call this original index. So store the index onto the attribute that we just named, original index. If I press A on here now and scroll to the right, you'll see there's our index 0, 1, 2, 3, 4, 5, 6, 7, etc. It goes right in order. But if I do it on difference and I pressed A here, you will see that it is still going in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But look right here. We go from 16 to 18. Number 17 is gone. But if I highlight number 18 here and scroll to the left, its index is actually 60. In fact, the original index is 1 here when it starts originally at 0. So now that we have that original number, we can subtract this new index that it actually is now, and we get that difference. So from here, we can just use a subtract node, plug one in the other, and we're doing original index minus the index. And we can write that back onto the original index. That's fine. You could write it into a new attribute if you would like, but I press A now. You could see on the right here, all of these are now 1s. And if you scroll down, there's 2s, a bunch of 2s. There's 3s now, 4, and 5 all the way in the bottom. So this specific spline has been split up into 5 different segments. So now if we did an attribute partition and we partitioned all of these points by the original index and pressed A here, you will see now we have just 1s. And if I pick a different one, there's just 2s of that specific spline segment. Pick a random one, there's a different one that's just all 2s. Again, a different one that's just all 2s. Basically what we've done is we had separate splines, and within those splines, we split it up further. Attribute partition just goes ahead and splits up your data into whatever you want that is different. So if you, for example, told it to partition by index, every index has a different number, so it partition every single point into its own data set. You can partition by position, by a value, whatever whatever you'd like. Everyone that is the same in that attribute will stay together. And if it's different, it will split it up. So cool. We now have our split paths. From here, I want to store this. Now, this is currently this spatial data type. I honestly want it to be a points type. So before I even actually do the subtract, I'm just going to take from the difference node, so for 2 point. I'm going to take the spatial 2 point node. I'm going to plug that into the subtract, and that will become a point type. This is because I want to use another named reroute declaration node, and I want it to be an output of a type point. And yes, I could put this here basically, but if I ever want to grab point information here at this point in time, I would need to convert it. So I might as well do that immediately. So this actually partition out. I'm going to just press F2 to rename it. I'll call this cut splines. So if we ever need to get these cut splines later on, we can. And by the way, to preview this, I could just drag out, do a create spline node, and do then a spawn spline mesh. I'll just put in a simple box in here just for demonstration. And if we took a look here, you can see there's our separate segments of our splines. Our kind of intersection areas are cut out, and we have separate sections where these cubes are spawning. So you know everything is working correct here. We don't actually need this. I'll go ahead and remove it. Now that we've separated out the splines into its own segments, that each segment has its own start and end point. So just like we did here with the filter element by index to get the first and the last, we can do the same thing over here. Of the cut splines, we'll grab the first and the last one. And if I debug this one now, you will see there's all our intersections. The T intersections have 3, the regular 4-way intersections have 4, and we have 1 in the dead ends. Cool. So now we need to kind of figure out which section they're in. And thankfully, there's a node for that. It's called cluster. It basically looks at every single section within a radius and makes those points have the same value effectively. Now, let me show you. The first thing I want to do is merge all these points together, because right now they're still all separated out by the spline. We want to have them now all be together as one set. And then we can use a cluster node. Now, I have PCGEx installed. That means you have a lot of PCGEx cluster nodes. We want the regular point operation cluster node. This is the default PCG one, and the cluster is going to be based around the intersection points back here. So you can right click, search for intersection points, grab those and plug those into the initial centroids. You don't need to change anything on here. In fact, if I press D to debug this, it will look exactly the same. But the important thing is the information here is different. And we can see the information by dragging out and search for visualize. This lets us visualize the last attribute that we create. In our case, on this cluster here, you can see it's outputting the information to a cluster ID. So by default, the visual attribute will do that cluster ID. You can see here, 13, 13, 13. The first number is the index of that original point. And if we fly somewhere else, you can see 14, 14, 14, 14. Go to a T intersection, 1, 1, 1. But watch what happens if I move this a little bit further out. Now we have a 16, 16, and a 1. So this is where you need to kind of be somewhat precise in your placement of your points. But once you have the actual measures in, it'll be much easier to say this street needs to go a little bit further in or out, and you'll kind of get the hang of it. Don't worry. But just know that now each of these groups have the same value. And because they have the same value, and we did just merge them, we can now split them up into its own sections. So we'll use another attribute partition, and we can leave it on last, but really we're filtering by this cluster ID. So you can leave it on last here, or if you want to be safe about it, you can put in cluster ID. So now if I press A on this attribute partition, I can go ahead and just select any one of the other pieces, and you'll see some of them have 4, some of them have 1, and on the right here we see there's the original index that it had that we stored earlier. We don't need that anymore, and there's our cluster ID. But the main thing is we have a different amount of pieces here for every single one of these based on how many it actually intersects. This is a dead end, another dead end, this is a T intersection. So what I want to do is store the number here of how many indexes there are as an attribute. There's a couple of ways of doing it. You could check how many points there are, or you can get the maximum index number. Maximum index number, if you had 4 inputs, will return 3, while trying to get how many indexes will return 4. I want to start at 0, so if it's a dead end, it has 0 intersections. If it has 2 intersections, that is a T. If it has 3 intersections, right, the original road has 3 connections, then it's a 4-way. So we'll use the actual index for this one, and I'll also use a new node that I haven't shown in the channel before called attribute reduce. Under metadata attribute reduce, we want to attribute reduce max here. So the input source, instead of last, we want to specify the index, and I want to make sure it's on max. So if I press A here, you'll see the first one says 0, the second one says 3, next one says 2, 3, 2, and basically it is now recording the highest index that this attribute partition had in whatever data set it was. So now we can store this back by doing a set attribute node. We'll plug this attribute reduce into this in B, and we're just going to store this as a new variable. I'll call it something like intersection intersection count. Because if we have 0 intersections, it's a dead end. So awesome. We now have a way of actually seeing how many intersections are there. Great. So now we can split it up by however many intersections there are. And we can do that first by filtering out the dead ends. I'll use a filter attribute elements here. Now for this filter attribute elements, the target attribute can stay at last. It will just be checking this intersection count, but you can absolutely just put that into the target attribute so you can have a safety net. And it also will tell you right here, what are we filtering here? Intersection count. By default, it would say at last. So at a glance, if you'd like to, you could type it in so you could see exactly what you're filtering. And then we just change it to use constant threshold of 0. Because the dead ends are 0, they will fail the greater than check. So the outside filter will be dead ends. Just so I don't forget, I'll toggle the comment bubble and I'll type in dead ends are outside filter. So the inside filter remains to be now the 3-way and the 4-way intersection. So we can go ahead and just take this and duplicate it. And now I'm going to check, instead of greater than 0, I'm going to check if it's greater than 2. You can also filter it by checking if it is exactly 2 or exactly 3. It should be fine, whichever one kind of you prefer. But by checking if that it is greater than 2, inside filter will be the 4-way and the outside filter will be the T intersections. So I'll just call this 4-way / T intersections. So I know the top one's 4-way and the bottom one's T intersection. Now let's take a look here. If I go into inside filter here and do a simple debug, you will see there's our 4 points. Okay. And they're not equally distant, which means that if I go ahead and try to create something in the middle by using something like a collapse points here, which by the way can be pretty much infinite size, and then debugging, you will see that it is slightly off center of that original intersection. It is especially noticeable if I do it on the T intersections. So on the T intersections, you could see it has moved the point pretty much off of this road. I do not want that. I want the T intersection to be where I kind of actually intersected. So how do we now move all these points back, whether it's on the 4-way or the T intersections? Thankfully, there's a note for that. It is called attract. Attract pretty much takes one set points and makes the other ones move to that location if you keep it on position, which is the default. But you can also attract an attribute, a rotation, or whatever you'd like. So before this collapse points, I'm going to just drag out and search for an attract node, and that's going to go before the collapse points. And the target here is I want to attract them back to the original intersection points, back where they used to be. And then I can change the attraction distance here to be something quite high, let's say 2000, and leave it here on default. It will attract the position of those points, which is all I really care about, is the position, to the original locations. Then it will collapse them. And if I plug both of these into here, so we can preview both the inside and the outside, you will see that, hey, look at that. The points are now actually in the center of these intersections. And when you're working with the curved lines, that doesn't really matter much. If it's something that's a little off, you can kind of adjust the curve, but it does matter a lot if it's a little bit off when you're trying to make a perfect grid, which is why I made sure to include some perfectly straight lines. Because if this is slightly off, if I disable the attract again, and I try to make a line from here to here to here, that is no longer straight. So that attract is actually very important. Okay, with that taken care of, let's set things up properly. The 4-way are going to be attracted and collapsed, but the 3-way need a little more logic, and mostly it's there to figure out which way is it facing, because it might be facing forward, right, left. It doesn't really tell you the direction, you just have a point. So by taking the 3 points and checking the distance here from the original to the new ones, we can figure out how far each one of these is. And if we record the distance as a vector, we'll know the direction each one of these is. They'll say 100 units in the X direction and 50 in the Y, let's say. And that kind of gets you the information of, compared to the current center point, the intersection, that one is that far away. And by taking that and normalizing it, we effectively get a forward vector. It's sort of like what you would use to know which direction something is facing, and less so how far away in that direction something is. And when we have that direction and we collapse the points, all 3 of those vector distances also will get collapsed and averaged out to an average vector of which way is it actually facing. So the one number that we'll have left between the 3 is the one where we need to face in that direction. And from there, we can go ahead and rotate in 90-degree increments if our mesh doesn't line up, which in my case is what we're going to do. Hopefully that all made sense. If not, let's go ahead and demonstrate it so you can see it in action. For the T intersections, we'll drag out and search for a distance node. And we want to make sure we're using spatial distance, not the vector operation, spatial. And we're comparing that to the intersection points. We're outputting it to an attribute, but we want to output the distance vector. And the source shape and target shape, we just want to know the exact centers of these. So from one point to the other point, check the distance. So if I pressed A here and I selected one of the data layers that had information here, and scroll to the right, you'll see there's our distance X, Y, and Z. And every one of these 3 points is slightly different. So now if we take this and normalize it by doing an attribute vector operation normalize, make sure it is the vector operation, and then we take a look at this one. Again, scroll to the right, you will see now these are between -1 and 1, so we know the direction. It is in -x here, positive y, positive x, negative y's, and it's not going up and down basically at all. So awesome. Now we're going to need to attract them and collapse them. We still want to do the attract. We'll just take care of that here, not before the distance, because the distance is important to have those actual original locations before we kind of tell it, hey, put it in the center. So we do want to attract after this normalized distance. Same thing, 2000 closest is great. Collapse points can be very high. The number in terms of its max doesn't really matter because we've already partitioned them based on the cluster. So each cluster already has its own thing. So we're just saying, hey, just collapse it into 1 point, whatever that cluster is. So you can be too low, but you can never be too high. You don't really need to have 10,000 here. Something like 5,000 would be more than enough. The point was to just show you that, hey, you cannot go too high in terms of the result. So now that we have this forward vector and it's all collapsed, we can go ahead and say, hey, convert that forward vector to the rotation. So we know which way the vector is facing. What angle is that actually supposed to be? So from the collapse point, drag out and search for make rotator. You want to do make rotator from X. It is going to complain because it cannot store it back onto what it was using. So we want to specifically say, hey, change it to rotation. Set it back onto the rotation based on the last vector attribute that we were using, which was set all the way back here on distance. That's why at last here is working. And now if we need to make any kind of modification to that rotation, we can just use a simple combine node here under attribute rotation operation. And if we need to rotate it, which I know in my case I do, I can rotate it here. Let's say this will rotate it by 90 degrees. Now this is all cool, but at this point we kind of have the points where we need to spawn things. How do we actually spawn the intersections? Well, we're going to need to create level instances that have a few things, starting with our intersection and to the connection points of that intersection. Basically, where do the roads reconnect to these intersections? So let me show you how easy it is to set those up. We'll start a brand new level here, and let's say I want to do a 4-way crossroad. I'll just bring it out and I'll put it at origin. Now it is quite tiny. Again, these meshes are a little small, so I'll go ahead and just scale the whole thing to be 10x. So great, we have the 4-way intersection itself, but I also want to, again, tell it where to connect the 4 sides of the road. I'm going to hold Alt and drag it over to the side, and now I want to change the mesh on this. Instead of the static mesh being this road, I'm going to search for arrow. It doesn't really matter which one I grab. Let's grab this S arrow, and that seems pretty good to me, and I'll go ahead and just angle it this way. Only thing is I want to rename it in the outliner, maybe just arrow 1, and then I'll hold Alt and kind of place these arrows in the other directions. The main thing here that is very important is that these are static meshes and not actors. So keep that in mind. They're static meshes, so with all 4 of them selected now, I can search for tag and give them an actor tag and give them something like connection. This is the connection point of this 4-way intersection. Now for convenience, I'll just take all of these and put it underneath this road cross path, and I'll just rename this to intersection. So by selecting all of them and holding Alt and drag, I can just move them all to the side. And what I'm going to do is make sure the intersection is selected as well as the arrows below it. And then I can just right click, go to level, create level instance. I want to make sure external actors are turned off. Center min Z is good, hit OK. And I'm going to put it inside of the assets level instances intersection section by calling it LI for level instance underscore 4-way intersection, and hit save. And you know you've done it correctly when you see in the outliner, there's your level instance. It has a new icon, and you see the intersection and all of the arrows, and you can move them all together as one. So awesome, that is now set up. I can go ahead and delete it, and I can reselect the intersection that we had before, Alt drag, and now on this intersection, I'm going to make it a 3-way. I have this road intersection path, so I'm going to swap this mesh with it. And you can see this one has now a wall here. So I'm going to take this arrow, and I'm going to delete it. And now, just like before, I select the intersection with the 3 arrows, right-click, level, create level instance, uncheck external actors, and I'll rename it to li underscore t intersection. Hit save. Now, this one, though, as you can see, went and put its position not in the center. Because we removed one of the arrows, I want to point here that it has moved it a little to the right. We want to keep that position in the center. There's a few ways of doing this. I'll show you one of them on this last piece when we do it, but to fix this, you could just click edit on it here in the detail panel, then go to the pivot and reset the position of the pivot here, and then hit save. And then you can reset the position of the location. You can see now it's back in its original spot with a position in the center, and it has saved over that level instance. So don't worry about that. You could do it the way I'm about to for the dead end, or you could always modify it after. Last one is a dead end. So again, I'll put it back to origin. And there's a few dead ends. I kind of like the rounded one. So I'll go ahead and again, remove 3 of these arrows that are not connection points. We'll only be left with this one. So by selecting both of these, again, right click, level, create level instance, uncheck external actors. But this time, instead of center min Z, I'm going to change it to world origin. And then I'm going to hit OK. And this is going to be our li_dead end. And you can see the pivot point has never moved and we're good. All that's left to do is take these 3 level instances, right click, go to asset actions, and all the way in the bottom, create PCG assets from levels. Now I'll go ahead and create the PCG files that we need to read from. Now those are created, we can go back here. So how do we actually use them? Well, there's a few ways you can do it. You can right click, search for load PCG data asset, and then you can plug it in here. So there's our 4-way intersection. And then we can just take our points and we can do a copy points node here to copy those points from the original to wherever we need those. Another way to do it is by taking the data asset and just dragging it in. That will also create this node. I'll go ahead and drag in the last one as well at this point. So we have the dead ends that we'll need over here. And this is the 3-way. I'll use a copy points here as well and here as well. Just remember that the actual data asset goes into the source and the original points are the target. I'm going to go ahead and add a named reroute node here because I want to store these just in case we need it for later. Again, we'll name it add named reroute declaration node, press F2. I'll call this 4-way intersections. Again, same thing here, named reroute declaration node, T intersections. And this final one, add another named reroute declaration node, F2 rename dead ends. And now wherever we'd like, we can grab the 4-way intersections, the T intersections, and the dead ends, and drag out, use a static mesh spawner, like all the way through. And because they're all being gathered from this data asset to use the mesh that we want to spawn, we just need to change the selector here to by attribute, mesh selector by attribute, and the mesh selector is called mesh. And you can know this by going here onto any of these, pressing A. And if you scroll a bit to the right, you will see there's our mesh, and that is the path of the actual mesh here. The arrow is from Niagara, but that's fine. And that's why we call the attribute mesh. The 4-ways here, the dead ends are wrong because, well, they don't know which way to face. So they're facing the wrong way. So we need to know which way they're facing based on whether it is the start or the end. You can see this one is correct because it's going this way, but this end one is not. And we need to change the rotation of these guys. Let's first fix these dead ends. To fix those, it's very simple. But the first thing we need to know is which one it is. Is it the start or the end? And the start and end here wouldn't really work that well the way we've been doing it before, just because this is the original full-length spline and not the segments. So what we can do is store where it is along the spline these points are. So the very first point will be 0, the last point will be 1, and we can filter basically is it in the second half or the lower half and kind of just get those 2 points. What I mean is over here in the spline sampler, we can go open attributes. We want to compute alpha. Compute an alpha value along the spline and write it to an attribute. We'll go ahead and turn that on. It'll go ahead and store it as alpha. So halfway along the spline, it'll be 0.5. A third will be 0.33. So depending on how far along it is, we know the value. So now we can just right click, search for filter attribute. We'll do a filter attribute elements and we'll check if it's greater than compared to the alpha. And we want to use a constant threshold again. And just for safety, we'll do 0.5. So if it is the second half, consider we only have 2 options here anyway. It's either the start or the end. If it is greater than 0.5, it is the end. Otherwise, it's the start. So we'll go outside filter into here. The outside filter will then go into the target here instead of where we were doing originally. And the inside filter will do a transform points node where we just flip the entire thing 180 degrees and then plug that into the target. And now you can see this is now correct. Fantastic. Now, as for the intersections, the reason why they're kind of still all angled the wrong way is because I forgot to do a little thing, which I said to the camera, but I didn't actually do, which is in the collapse points, we're just collapsing the position, but we actually need to also collapse the distance. Because as I mentioned before, we need to get the average distance to get the average normal direction. And when we do that, you can see there's our intersection here facing the correct way. Intersection here is facing the correct way. And here it's facing the correct way. So there we go. So now our intersections are all facing correct. Fantastic. But one thing to notice here is we are actually still spawning these arrows. We don't want to spawn these arrows. We want to filter these out. These are there just for the connection of the roads. I'll just drag my static mesh spawner here to the right, and I'll make this a little more normal by dragging from these connections all the way to the end here, setting up the reroutes, and doing something like this. This is just so we still have the named reroutes if we need to use them later, but I can tell that, okay, all of these are going through here. And the main thing I want to do here is filter out those arrows. So I'm going to right click, search for filter attribute elements, and I'm going to check if the operator is equal to connection. Because if we go to any any one of these and press A, you will see all the way on the right here, we have an attribute called connection because we gave these 4 arrows the actor tag connection. And so it knows the other ones, hey, they don't have that. So now we can check, is the operator equal to connection? I'm gonna make this a constant threshold of a type of a Boolean, and we're gonna check if it has the connection. If it does, that means it is one of those connection pieces, but if it doesn't, that means it is an intersection and the original mesh, and we should spawn it. And now we have removed those arrows. So arrows are gone. All that's left to do is the actual connection here. So now for the rest of the points, which are all the connection pieces, we can go ahead and merge them all together by using a merge points node. What we want to do is, if we go ahead and debug, we'll take a look at them. I'll set it to be absolute point scale of 5. You can see those are all the connection pieces of all of these. Those are locations of our connections. That's where we want the rows to continue from. So what I want to do is take and attract the original splines, the separated ones, to these locations. So that way, instead of connecting, let's say down here, it'll actually move these points to be connected here where we want it. We can do that again with the attract node, but we want to attract the original cut splines to these merged points. Now we don't want to just adjust the position. We also want to attract the rotation from and to. If I would try to debug them now, you see it's a little bit better, but the problem here is the distance is just not high enough. Let's crank the distance to something like 1,000. And now you'll see that, hey, the first few points are gone within 1,000 units, but they're now exactly attached to this point. Now, all of those points within here are actually stacked on top of each other. So we actually need to go ahead and remove all those duplicate points. So we'll do that by just collapsing them using a simple collapse points. Nothing special about this one. And now if we wanted to take a look, we can use a create spline node and use a spawn spline mesh. And here we'll go ahead and open the descriptor. I'll use the road straight here, which is just this piece right here. And if we take a look, oh boy, we have a few issues. Starting with the fact that they're not quite working very well because they're a little small. So let's fix that. So before the create spline, we can add a transform points node. And just like I did in the intersections, I'm scaling them to be 10 times bigger in all axes. Okay, so this is better. So next, let's go ahead and adjust the rotation of the tangents here, specifically add the connection points. So that way it faces the correct way and it's nice and curved. For that, we will need a loop node. So I'll go ahead and create a new PCG graph. It'll be an empty graph. I'll call this PCG loop underscore rotation to tangent. Then I'll go ahead and grab it, drag it in, and choose the bottom loop node option, and then I'll double click to open it. The input here is going to be of a usage loop, allowed times point, and set to required, and the output here is just a normal point set to normal. So effectively what we're going to be doing is we're going to be filtering out the first and the last points, setting the tangent based on the rotation, and then reusing the tangents that were stored before for everything in between. So to get the first and the last index is very easy. We can just grab this filter elements by index that's already set up for us, put it here, and plug it in. And then we need one more time because the first one is filtering out the first and the last, but it's not giving us the output. So we want to output discarded elements. And now we have the in filter is just the 0 and the 1. We want to specify just 0 and output discarded. So this is index 0, this is index -1, and this is everything remaining. So the first index I'm going to drag out and search for multiply. And what I want to do is do a point rotation, then hit a plus again and add an extractor rotator forward, or it's $rotation.forward. This is the forward direction based on the rotation, and I want to multiply that by a value. Now, for my experience, the value here is pretty nice, around 1,000 or 1,500. So what I'm going to do is hold 1 and left click, which gets us a float constant, and I'll just type in 1,000 in here. You can play around with this value. I'll multiply that by 1,000, and for this multiply, we don't want to put it back onto itself. We want to specifically call this one leave tangent. The name here is important. So this is the leave tangent, and the out filter, which is the back, is basically going to be the same thing. Out filter into in A, create constant into in B, just like the top one, but here it's going to go into another multiply node and it's going to multiply it by -1. So it's the opposite direction. And then we need to merge it all together. I'm going to right click, merge points node. Now the order is very important here. So I'm going to add 2 more pins so we make sure the order is exactly correct. This can go to the output, but the input for the first one, as you might imagine, is the first point. The next one in line is all of the remaining points. And the last point here is, of course, the last point. If you mess up the order on this, you will get bad results. So order is very important. And don't forget to, on the second multiply, because we did just duplicate it, changing it from leave tangent to arrive tangent. So the first point is the leave, the second one, or rather last one, is the arrive. Now here, we can go ahead and plug this through right before the transform points node. And then on the create spline node, we can turn on apply custom tangents. Now we're going to have some issues. Start with the fact that what's going on here? This seems okay where the connection is, but what happened to everything else? That is because we don't have them enabled for all the in-between. So if we go all the way to the beginning here, open the attributes for the spline sampler and turn on compute tangents. So that way it stores the default ones. We can take a look and it's kind of okay. And while on this one, it doesn't seem to be displayed very well. On the test that I was doing previously, you might get something like this, where the in-between just is completely broken. It seems like on the current one that I'm doing for the tutorial, the issue is not nearly as bad. It's not great, but it's not as bad. And you can see here, on a lot of these, it's fine, but on some of them, it's really, really, really bad. So let's make sure that this is not a problem for you guys, which is why we have PCGEx installed. I'll go ahead and turn off the compute tangents on this original spline sampler. We're not going to be using those. Instead, before this PCG loop rotation to tangent, I'll make some room. I'm going to go ahead and get my distance increment, row distance increment, and I'm going to go ahead and use an add attribute parameter here. I'll go ahead and add this as a parameter. Now this is important. It needs to be a data type. So it needs to be at data dot whatever you want to call it. I'll call this path distance. But the main thing here is it's not just path distance, it's at data dot path distance. The reason this is very important is because when I use the PCGEx resample node, it wants something from data. Unfortunately, it doesn't specify that, but for the resolution here, that is the resample of the splines resolution. I want to have that be an attribute, so I can go ahead and click this icon here. That makes it an attribute. And now if I type in path distance, it is grabbing it from that data. Just to show you, if I go ahead and remove the at data dot and press enter here, it will complain that path distance does not exist, even though you are looking at it, it is existing. And that is because it wants it at the data level instead of the point level. So all this node is doing is it resamples the entire spline with this distance, and I have redistribute evenly. So that way, even though we kind of scrunched in the connections next to the actual intersections, right? We removed those points. This will make sure that the points are still spread out evenly. So that way, if you have something like a dashed line going along your spline on the road, it will not look like some areas are really scrunched up and some are really stretched out. This kind of fixes all of that. Just awesome. And we're also going to use PCGEx to write the tangents from here. So after the resample, I'll use the write tangents node, and then I can go ahead and just take that and plug that all the way through. So instead of going from the original spline, we're going off of this new resampled spline. As you can see, it's still kind of a little odd here. This is probably just too odd of an angle. One thing I do want to do though is on the resample, I have found that if you change the truncate here to ceiling, you will get better result, as occasionally, depending on how far you draw out your lines, you might get a weird dead end that is kind of split off from the main road network. Ceiling just fixes that issue. So let's take a look here. This one is kind of odd here, and that's just because I'm kind of trying to force it at a really bad angle. Let's go ahead and kind of fix this up, and there we go. At a better angle, we have a better result, of course. Same thing here. We're just trying to push it a little bit too far in this angle, but that's to be expected. We can adjust the paths here to be a little bit more or less, but watch out. If you go too far in kind of one direction or another, you will get something like this. All this is just the points are kind of confused because you kind of have two little bit overlapping, but not overlapping enough. And if I adjust them, you can see now we have a nicer kind of dead end. We can just adjust here to be a little straight or a little more curved, whatever we want here. But we now have straight lines, curved lines, whatever we want. And if we want to, we can just drag out a new one. Let's say this one right here. I'll just drag it out and I can just put it anywhere I want and it'll automatically create a new intersection. I can even angle it a little bit more odd, but just keep in mind that when you do an angle like this, it doesn't work. It really does need to be, at the current moment, more proper intersections. But even still, you can go ahead and connect it, create yourselves another 4-way, another 3-way, and go on. Now, I know this has been a quite long video, and I really appreciate you guys sticking through it as I try to explain as much as I can about this entire process. I did not want to split it up into multiple. I wanted to give you guys, here's the video on how to do all this. Splitting it up just felt wrong. So thank you guys for making it this far. I also want to give a big thank you to all my supporters on Patreon. Thank you for supporting what I do. It really means a lot. And if you'd like to join the community, link to everything is down below. Come join. And just because we have created the roads does not mean we're done. The plan right now is to populate the roads with stuff. Maybe some intersection traffic lights. Maybe some lights along the road. Let me know your suggestions in the comments below. I'd love to hear them. But in the meantime, if you want to check out some more PCG tutorials, I highly recommend this one. You know you want to learn some more about PCG.